The Himalayas contain some of the world's highest and harshest environments. Across decades of expeditions, clear patterns show which mountains are simply difficult and which are consistently deadly. Fatality rates rise due to unpredictable weather, avalanche-prone terrain, technical routes, and the limits of human physiology at extreme altitude. Rescue options remain limited, and safe descent routes are often narrow. This documentary ranks these peaks using verified data and historical records, explaining the real factors that make them the deadliest in the Himalayas. Cho Oyu rises 8,188 meters on the border between Nepal and Tibet. It is often described as the most approachable of the 14 8,000-meter peaks, yet expedition data shows that the mountain carries risks consistent with extreme altitude. The standard northwest route begins with long glacier crossings where hidden crevasses are a constant concern. Snow bridges can weaken without warning, creating hazards that are not always visible from the surface. As the route climbs higher, the terrain shifts to steep ice and firm snow slopes. These sections become especially difficult during warmer periods, when surface layers soften and stability decreases. Despite its reputation, Cho Oyu exposes climbers to the same physiological pressures found on every major Himalayan peak. Altitude-related illnesses remain a leading cause of evacuation and can develop even in well-prepared teams. Weather on the Tibetan Plateau adds another layer of uncertainty. Clear mornings can turn into low-visibility conditions within hours, reducing navigation accuracy and increasing exposure to cold, wind, and disorientation. Because Cho Oyu is positioned away from the more commercial routes found on peaks like Everest, logistical support is thinner. Rescue options are limited, and delays in response remain common on the upper mountain. The descent is another critical phase. Fatigue, dehydration, and reduced concentration often coincide with the most hazardous sections of the glacier. Several incidents recorded in expedition reports occurred after successful summit pushes, showing how endurance becomes a decisive factor in overall safety. Cho Oyu's danger comes from the gap between expectation and reality. Its slopes may appear moderate compared to other 8,000-meter giants, but the combination of altitude, hidden crevasses, shifting weather, and remote positioning keeps the mountain firmly within the category of high-risk Himalayan peaks. Manaslu, rising 8,163 meters in central Nepal, is widely viewed as one of the more attainable 8,000-meter peaks. Yet expedition records show that its slopes contain some of the most unstable snow conditions in the Himalayas. Avalanches account for the majority of fatalities on the mountain, including several incidents that affected large guided groups. The standard northeast route crosses long snowfields where wind-loaded slabs, hidden weak layers, and steep rollover sections create continual instability. The route begins with glacier travel through crevasse zones that shift each season. Snow bridges can collapse without clear visual indicators, especially after fresh snowfall. Above Camp 3, climbers move beneath serac formations that have a well-documented history of icefall events. These hazards require precise timing, often forcing teams to move during colder early morning hours when the snowpack is more stable. Manaslu attracts a high volume of guided expeditions, which changes how risk manifests. On narrow sections, bottlenecks can form, increasing exposure time beneath seracs and on slopes with a known avalanche history. Larger teams also mean more foot traffic, which can stress fragile layers in the snowpack. Seasonal transitions influence stability more than on many other 8,000-meter peaks. September storms, shifting monsoon remnants, and temperature swings create rapid changes that forecasting models cannot always predict. Recorded accidents show that even experienced teams have faced unexpected slides during otherwise calm weather periods. Despite improvements in forecasting, equipment, and fixed-line management, Manaslu remains defined by hidden instability. Survivors often describe the mountain as quiet, with long smooth slopes that give little indication of underlying weakness. Its risks are not dramatic in appearance but are embedded in the structure of the snow itself. Understanding these patterns is essential before examining the next peak on the list, where technical challenges dominate the danger rather than snow conditions. Makalu stands 8,485 meters above sea level, forming a sharp, four-sided pyramid on the Nepal-Tibet border. Its geometry defines its difficulty. The mountain's ridges are narrow, exposed, and consistently steep, creating one of the most technical environments among the world's highest peaks. The standard route leads toward Makalu La, a high col where teams often struggle to establish stable camps. Wind exposure is extreme in this zone, and tents are frequently damaged or destroyed during storms. Above Makalu La, the terrain becomes even more demanding. The final summit pyramid combines rock outcrops, mixed climbing sections, and sustained ice slopes. These features require precise footwork and reliable ice conditions, both of which become harder to maintain at high altitude. Historical expedition records show that the upper ridge is one of the key danger points, where climbers describe being fully exposed to strong crosswinds from the jet stream. Makalu sits directly in the path of these upper-level winds, which significantly limit the number of usable weather windows. Summit attempts often hinge on narrow breaks in the jet stream, forcing teams to move quickly when conditions allow. Because the mountain attracts fewer expeditions than nearby Everest or Cho Oyu, there is less fixed-line support, fewer established camps, and a greater reliance on technical skill and route finding. Accident patterns on Makalu frequently occur on the upper slopes, where steep angles and wind-polished ice reduce margin for error. The descent adds further strain, as climbers must reverse technical sections after hours of exposure and fatigue. Success on Makalu is strongly linked to timing, stability of the snow and ice, and the ability to operate efficiently in harsh, wind-dominated conditions. With Makalu examined, the focus now shifts to another Himalayan giant defined by weather and snow instability rather than technical terrain. Dhaulagiri I rises 8,167 meters in western Nepal and remains one of the least visited 8,000-meter peaks. Its isolation west of the Annapurna range shapes almost every part of the climb. The approach to base camp requires long travel through steep valleys and the ascent of the French Pass, a section known for difficult terrain and rapid weather changes. This distance from major trekking corridors contributes to the sense of remoteness that many climbers report. The mountain's danger begins with its weather systems. Dhaulagiri receives strong winds and sudden storms that build quickly around its massive south and northeast faces. These systems influence the standard northeast ridge route, where long snow slopes often accumulate fresh snowfall. The Himalayan database shows that avalanche incidents have been a major source of fatalities, especially during spring climbing seasons when warming temperatures destabilize upper layers. Limited foot traffic means fewer established fixed lines and less route maintenance. Climbers must rely heavily on their own navigation, particularly on the upper mountain where visibility can drop rapidly. The upper slopes include angled snowfields and sections of wind-packed terrain that become difficult after storms. Route-finding errors in these zones can lead to increased avalanche exposure or entrapment in unsafe terrain. Because Dhaulagiri sees fewer expeditions, logistical support is thin. Rescue operations face delays, and weather windows are harder to predict without the constant updates available on more commercial peaks. The combination of steep angles, snow instability, and rapidly shifting storms produces a climbing environment where small misjudgments can escalate quickly. Dhaulagiri's risk is not defined by a single technical obstacle, but by the cumulative effect of isolation, unstable snow, and reduced support. These factors distinguish it from nearby peaks and highlight why it holds a historically high fatality percentage among 8,000-meter mountains. Kangchenjunga stands 8,586 meters on the remote border between Nepal and India. Its isolation shapes every stage of the climb. Reaching the mountain requires long approaches through sparsely populated valleys with minimal infrastructure, a contrast to the busy access routes found around Everest. This remoteness reduces rescue options and limits support, making logistics more demanding from the start. The ascent itself is defined by complex terrain. Historical expedition records show a steady fatality rate linked to deep snow, hidden crevasses, and unstable slopes. The standard routes involve long, technical sections where climbers must manage altitude, navigation, and timing simultaneously. Near the upper ridges, cornice formation becomes a critical hazard. These overhanging snow structures can break unexpectedly, especially during periods of warming or shifting winds. Avalanche risk also remains high on Kangchenjunga. Weather systems influenced by monsoon transitions often produce heavy snowfall, which accumulates on steep faces and couloirs. Predicting stability is difficult, and climbers frequently report rapid changes in surface conditions. Establishing high camps adds another challenge, as safe, protected locations are limited on the steep upper mountain. Kangchenjunga carries cultural significance as well. Many expeditions choose to stop several meters below the true summit out of respect for local traditions. This practice creates a unique psychological moment, where the final goal is intentionally left untouched, reinforcing the mountain's status as more than a physical challenge. Compared to Everest or K2, far fewer climbers attempt Kangchenjunga each season. With less traffic comes reduced fixed-line infrastructure and fewer established tracks through dangerous sections. Teams rely heavily on their own route finding and decision-making, increasing the overall difficulty of the climb. Kangchenjunga's danger is a combination of remoteness, technical terrain, unstable snow, and cultural considerations, a peak where both geography and tradition shape every stage of the ascent. K2 rises 8,611 meters in the Karakoram and is widely regarded as the most technically demanding of the world's high peaks. Its steep faces, unstable rock, and narrow ridges create continuous exposure from the lower slopes to the summit. Unlike Everest, where fixed routes and wider ledges offer brief relief, K2 provides almost no terrain that allows safe rest or recovery. This sustained difficulty is reflected in its comparatively low number of successful summits. The most dangerous point on the standard route is the bottleneck couloir. This narrow gully sits beneath large overhanging seracs that have a documented history of collapse. A failure in this area can affect multiple climbers at once, and historical incidents underline how little control teams have over objective hazards at this altitude. The steep angle of the bottleneck also forces climbers to move slowly, increasing the time spent under unstable ice formations. Weather adds another severe challenge. The Karakoram is exposed to strong jet stream winds, which limit the number of viable summit days each season. Storms develop quickly, and conditions that appear stable at night can deteriorate within hours. These patterns explain why teams often wait long periods before attempting a summit push and why many expeditions turn back before reaching the higher camps. Rescue feasibility is extremely limited on K2. Above 7,500 meters, aircraft cannot operate, and ground-based evacuation is nearly impossible due to steep, technical sections. This reality means that climbers must rely entirely on their team in emergencies. The absence of external support contributes to the mountain's consistently high fatality rate. Even with improved fixed-line management and stronger team coordination, K2 remains the benchmark of extreme difficulty in high-altitude mountaineering. Every section demands precision, and as many climbers have noted, small mistakes on K2 have immediate consequences. Nanga Parbat stands 8,126 meters at the western edge of the Himalayas, where the ranges meet the Karakoram. Its size, structure, and history have defined its reputation as the Killer Mountain. The south side is dominated by the Rupal Face, a wall rising about 4,500 meters from base to summit. It is one of the tallest mountain faces on Earth, and its scale creates long, uninterrupted sections of climbing with almost no terrain suitable for safe recovery. Early expeditions in the 1930s and 1950s recorded some of the most tragic events in Himalayan mountaineering. Those incidents established the mountain's fierce reputation, but the underlying risks remain the same today. Steep slopes, unstable terrain, and harsh weather systems that sweep across the mountain from the Karakoram-Himalaya junction. Storms often build rapidly, reducing visibility and increasing avalanche danger on both the Rupal and Dhaulagiri sides. The Dhaulagiri routes present a different but equally serious set of hazards. Serac collapses, mixed ice and rock sections, and steep couloirs form key obstacles. Accident records show that avalanches and icefall events remain leading causes of fatalities on this side of the mountain. Because Nanga Parbat is less commercialized than peaks like Everest, fixed infrastructure is limited and route conditions vary widely from season to season. Access adds another layer of difficulty. The approaches to base camps are long, and helicopter access is restricted by terrain and weather patterns. Rapid evacuation is often impossible, especially at higher camps, where exposure is constant and technical obstacles prevent fast ascent. Survivor accounts frequently describe the psychological pressure created by the mountain's massive vertical relief. The combination of scale, isolation, and instability defines Nanga Parbat's danger. These factors continue to shape modern attempts and explain why it remains one of the deadliest high-altitude climbs in the world. Annapurna I, rising 8,091 meters in central Nepal, has long held one of the highest fatality-to-summit ratios among the world's 8,000-meter peaks. Its danger is rooted in terrain that consistently produces avalanches, unstable snowpack, and narrow couloirs that offer little margin for error. Historical expedition data from the Himalayan database shows that the south face is particularly hazardous. This wall features steep slopes loaded with layered snow that can release large slides with minimal warning, reflecting the mountain's reputation for sudden and unpredictable changes in condition. Even the standard north route contains exposed sections where timing is critical. Afternoon warming can weaken surface layers, increasing the likelihood of instability on steep traverses and gullies. Climbers frequently note that Annapurna offers very few safe weather windows, and those windows often close quickly as storms form around the massif. This unpredictability is a defining characteristic of the mountain and contributes heavily to its accident history. A significant portion of Annapurna's fatalities occur during descent. Exhaustion, fading daylight, and deteriorating weather combine to make technical sections more dangerous on the way down than on the ascent. The presence of hanging seracs and shifting snow formations intensifies these hazards, especially after fresh snowfall. Despite advances in forecasting, navigation tools, and equipment, Annapurna remains one of the deadliest high-altitude challenges. Expedition improvements have reduced some risks, but the fundamental geography of the mountain, steep faces, avalanche corridors, and exposed traverses, ensures that objective danger remains high. Climbers often describe Annapurna as a peak where conditions change without warning, creating a constant sense of exposure even for experienced teams. This consistent pattern over decades explains why Annapurna ranks among the world's most dangerous mountains. The Himalayas contain some of the highest concentrations of objective danger in global mountaineering. Across Annapurna, Nanga Parbat, K2, Kangchenjunga, Dhaulagiri, Makalu, Manaslu, and Cho Oyu, several patterns remain constant. Unstable snow, avalanche corridors, steep technical terrain, remote access routes, and the limits of human performance at extreme altitude. Historical expedition records clearly show how weather volatility, narrow climbing windows, and difficult descents shape the fatality rates of these peaks. Modern forecasting, improved equipment, and stronger team coordination have reduced certain risks, but none of these advancements can overcome the physical environment of the high Himalayas. Rescue options remain restricted, and small errors can escalate quickly in thin air and cold temperatures. The essential message is recognition, not dramatization. These mountains demand respect. Survival depends on judgment, preparation, and an understanding of the real hazards that have defined Himalayan climbing for decades.